Okay, percent composition. If you'll flip to percent composition problems. The first problem, it just wants to know what's the molar mass of ibuprofen. We need that for the problems below. So again, molar masses, carbon. I'm still on the other problem we were doing. Carbon has a mass of 12.01, and there's 13 of them. Hydrogen has a mass of 1.01, and there's 18. And oxygen has a mass of 16.00 times 2. So this is 156.13. This is 18.18, and this is 32. Okay, we had to add them up to get to our total. Let's see, I have 18 in there, 156.13. Okay, so 188.13 grams per mole. That's the molar mass. Did I mess up? 156.13 plus 18.18 plus 32. 206.31. I thought I had said to add the answer from before that I had, but I guess I didn't. 206.31 grams. Okay, problem 2 says, what is the molar mass of the hydrate sodium carbonate decahydrate? And it gives us the formula Na2CO3 times 10 water molecules. And it says when a salt crystallizes from water solution, it binds the molecules in its crystal structure. It is called a hydrate. We just did some hydrate problems. So this is the same thing. Okay. Go ahead and solve for the molar mass of the sodium carbonate with 10 water molecules. All right, so Na2CO3.10H2O really means to add the 10 water molecules. So Na2CO3 by itself had a molar mass of what? What did it come to? 105.99 grams. And then the 10 water molecules had a total mass of 180.20 grams. So combined, we end up with a total of 286.19 grams. Okay, so we just add the two parts together. Okay, going on then to number 3. Number 3 says, what is the mass percentage of oxygen in ibuprofen? And then it says, what's the mass percentage of water in sodium carbonate decahydrate? So it's asking about 2 different molecules. This is 2 separate problems. 2 separate problems. Okay, so number 3, the first problem. What is the mass percentage of oxygen in ibuprofen? That's what we figured out in number 1. How much is the mass, the percent of oxygen? So that's going to be equal to the mass of oxygen, 32, divided by the mass of the total molecule, which is 206.31 times 100. And that's going to be equal to about 15.5%. Okay, the second part is asking what's the mass percent of water in the sodium carbonate decahydrate. Okay, so mass this time of water is equal to the mass of the water. How much was the mass of the water? This is in the second, the sodium carbonate, the second. Yep, the 180.20 grams from right here. And the total mass of the molecules combination, the hydrate, was 286.19. And again, times 100. That's going to give us a final answer of, looks like about 63%, 62.97%. Okay, so approximately 63% for this step. Right, let's look at the wording on number 4. Number 4 says, what is the percent composition of Cu2S? And then it says the name of that in word form is copper Roman numeral 1 sulfide. Well, it's not asking what's the percent composition of copper or what's the percent composition of sulfur. So when it does not say a specific item, it's asking for all the elements. Okay, so you've got to do the percent composition for copper, and then another piece is the percent composition for sulfur. Okay, before I can do this, what do I need to know? How much is the mass of copper total, and what's the total molar mass? Okay, so copper times 2. So I'm going to just put the little 2 there. Copper times 2. Its mass is 127.10 grams. Sulfur, there's only one of them, and sulfur's mass is 32.07. That means the total mass is 159.17 grams. So the molar mass for the whole thing. Okay, so if I know how much the copper portion weighs, I need to divide by the total molar mass. and then times 100. When we do that, we end up with about 79.9%. And about 20.2. Yeah, that's because we're rounding. If we went out more decimal places, it'd come out perfect. I have this comes out to 20.15. This is 79.852. So if we went out more places, it would be perfect. But we're at like 100.1. Okay. So that's the percentage here, rounded. Okay, go ahead and complete the remainder.